So welcome again. We are about to start the lesson called Bicycle, and the name of the lessons come from this idea that every lesson is creating a more complex data science project. They all should be fun. They all should be self-contained and useful. But as we progress throughout the workshop, things get a little harder, more complex, but also more fun because those tools take you farther down the road. You can go travel much farther with a car than with a scooter, for example. So yesterday we covered the first two lessons, the skateboard and the scooter, and we also covered setup that consume an entire block. We overviewed the toolkit that we need. We learned that GitHub are friends, RStudio are friends, but at the core of all of those tools there is RStudio, because RStudio provides an interface to every other tool, and together those tools are very commonly used in data science and very needed in a team like ours in 2 degrees investing, where we collaborate very closely with others. So our work in our computers needs to go out to the world, share through the internet with others, and then they need to be able to pull that work and extend it. So the first lesson introduced us mostly to the syntax of R, to what it is, an rmarkdown document. I didn't show how to create one from scratch, and I'll do it now in a moment. We learned how to. So also we learned yesterday. Sorry, going back. What are the steps of the data science process, and most of the lessons touch on many of these elements. In general, what we need to do is first import some data, then to tidy it in a way that is easy to work with, and then we transform the data, for example, selecting columns and rows. Then we visualize it with generating plots. We might create models that we haven't seen yet, but we will in the last lesson. And then when we are ready, we understood something, we communicate our understanding with the world. So for each lesson, there is something about each of those topics as much as we can. We learn how to read data with readr. We visualize data with ggplot2, which is a package. We learn that there is a syntax called the pipe, a way to compose functions called the pipe that comes from the tidyverse, and you can also do it in other ways, like composing functions by, for example, nesting them. And we discover some of the goodies of the format, of the output format, rmarkdown GitHub document, because for free you get basically a web page on GitHub for the rendered version of your report. On the second, on the scooter lesson, that introduced us to some of the tools that are more common in every data science project. For example, filter and select as tools to transform data and find exactly the data that you need in a potentially huge data set. And we also introduced this idea of iteration at higher level. Every programming language has for or an equivalent of for to iterate over different elements of a list, and therefore perform data science tasks at scale. Not doing things repeatedly by copy-pasting, but doing them repeatedly by expressing in code what is the repetition that you want the computer to do. At a low level, you can use a for loop, but it doesn't have to be used. There is more expressive ways to do that. That's a little bit of a hard concept to grasp, and I didn't do a very good job explaining map yesterday. My intention was to just introduce the idea, and hopefully the idea will become clear with practice today. Day 2 is now, we're going to be now talking about this lesson called Bicycle. This focuses on the stage of tidying data. So this stage here, and it is also the focus to So in terms of so tidying data, and we are going to be using some of the kind of more powerful ways to iterate, and more elegant ways to iterate within the tidyverse, which is this idea of creating groups, defining groups in your data, and then doing the same actions that you do in an entire data set now magically happen within groups. So this idea of grouping data, that we haven't yet seen that. So these two big ideas. So let's jump to the lesson, and instead of probably reviewing the objectives or previewing the objectives, we can review later what we have achieved, the takeaways. So I'm gonna jump to my R environment. And I'm going to be also demonstrating, how we have been also working with our other tools other than R. So with use these and the branches and the pull requests and all of that. So before I get into that, do we have any question, any comment? Okay, we're good to go. So I'm, from yesterday, the project changed. I modified the files that we're going to be covering today, fixed a few things, removed a few things, added a few things. So the first thing you would need to do is to kind of update your project so that you get the changes that happened upstream in the main source of truth, that is the repository called tidyds on the GitHub organization 2 Degrees Investing. You have a clone of that called a fork, more precisely, on your own user account, and you have been pulling and pushing commits to and from there, but now you need to get stuff from the upstream repository. So maybe one thing you want to do now is to run PR pause if you are in a branch different than master. If you are on a branch that is master, then PR pause might fail, saying that you are already on master. So you may also get a message saying that you have uncommitted changes. If that's the case, you may need to decide if you actually need to create a commit to kind of save your work or take a snapshot of your work at that stage. That's so that we are now ready to create a new pull request, to initialize a new pull request if you haven't done so yesterday. If you haven't done so yesterday, then you can stay on the branch where you are. So in my case, I think I have created a branch scooter. Maybe I did, and I removed it. And actually, one thing I would like to discuss is how to remove branches. So if your pull requests, your previous pull requests have been merged, for example, you can now remove them. So how you do that is you use the function PR finish. So sorry that I kind of introduced this topic right away, but I remember that I haven't covered that. So with PR finish, and remember that the README file should have information about these PR helpers. I probably forgot to talk about PR finish. So PR finish will, if you are on a branch, in this case, for example, let's change to the branch 02 Scooter Mauro, and I did that from this menu here. With the function PR finish, that will check what's happening upstream. That will check what's happening in my origin repository as well. We'll try to synchronize everything, and then it will create, remove all the settings that are needed. Here, let's see what the error message says. It says that the origin is behind, meaning that now locally I have some changes that do not exist on my origin. So, and it's telling me what to do. It says, please use PR push. So let's do that, PR push. So just to clarify once again. So I may have brought changes from upstream, and now the state of my repository locally is different, it's more advanced relative to how it is on my own fork. So I push first so that I update my own fork, and now it's kind of in sync with my local fork, with my local clone. And now let's try PR finish again, and now it worked well. I get no error message. So that should also have removed that branch from the menu. So if I go here, that CO2 branch should not be. Maybe I need to refresh. Let's see, with this little arrow thing. Yeah, there you go. It's gone. There may be some records of this branch here, and my experiments yesterday suggest that that might be a design decision by the maintainers of the use this package, or it might be a bug. In any case, you don't need to worry about that. What you need to worry about for now is the first branch that appear at the very top where it says local branches. For the other ones, they may cause some trouble in special situations, but I don't want to kind of get into that kind of rabbit hole right now. So, okay, yes. Mm-hmm. Exactly. So this is a good thing to clarify. If your work is still ongoing, you don't want to remove that pull request branch. So in your case, Daisy, I think, let me see. I'm now going to, let me bring another window to screen. I'm now using, I'm now going to the pull request tab on the main repo. And I see that Scooter, the PR Scooter for Daisy, is still open. And let's see what it says. I have reviewed that, and I noticed that the file name here is my name instead of yours. So as a way to kind of practice this idea of working together in a little project, I ask you to, for example, change the name of the file. So maybe for you, maybe don't delete that branch right now and use this as an excuse to practice, working with pull request reviews. So your work is going to be to go to your file, change. So in that branch, change the file to your name. Now, if you can follow and do it now, go ahead. Otherwise, you can do it later. So that file should say Scooter Daisy as opposed to Scooter Mauro. And then you create a commit, you push. And when I see that that's correct, then I merge it, right? And only then you will remove that branch. For everyone else, I already merged their branches. So they are good to remove them. They are good to PR finish. When you're done, that branch, the main goal is to remove it from the local repository, but my liking is to remove them from everywhere because you don't need the branch anymore. The change is already into the main repository. So the branch serves no goal, and it kind of contamines the, your ecosystem of tools there. To the point that can cause an error. So that's why I was saying that I prefer to remove them all, but I see that there are some leftovers, and those leftovers are the branches that are the equivalent of your local branch, but on remote repositories, either upstream or in origin. In this case, in origin, because we are using the triangle setup. So when you created a branch locally and pushed, then automatically when you pushed, you created a branch with the exact same name on your fork, the one that has the name origin. When you do the function PR finish, you remove your local one, but you may have a leftover of the branch on your origin, and that's something that I dislike, but it looks like it's a design issue with this. Okay. The branch should be there. Yes, if you delete it now, you mean? Yeah. Yeah, that's okay. One thing we could try is there is a function that I didn't cover, which is PR fetch, which is for mostly for maintainers. So if I see that your PR, for example, has the number 15, because I see that on the screen, let me bring that again. So your PR has the name 15 here, right? It's the PR number 15. And if you see the link, it also has a 15 there somewhere. So what I'm going to do is I am going to fetch that pull request. Let me see in which branch I'm standing now. I'm on master, that's good. So I'm going to fetch 15. So that should bring locally a copy of that branch that exists on your fork, right? And the same thing I think you could do with yourself. I think you could run PR fetch 15 and you should get your own branch back again, I think. You did? Okay. Good. I mean, all of these things are amazing. It's great that we expose them like live, because they will happen sooner or later, and we want we there to help each other. So great. Okay, so as you can see now, I'm standing on your branch, and I could do the change myself, and actually I will, just to demonstrate how I can push to your fork, which sounds like weird, but I can. So, once you submit a pull request to someone's repository, the maintainers of that repository have the ability to add commits, because you have given them the permission to start adding stuff to your own fork. So I'm going to navigate here to the file scooter Daisy. Okay, it looks like, is it possible you changed it? Maybe, okay, so maybe the file that was, I'm not seeing it here. Let's see, scooter you. Okay, maybe you do the change, or we work on this later. I'm surprised I don't see something that says, okay, so this is the name of the branch. Okay, give me a second, because maybe I think I'm confused to what I think I'm looking at. The file is called skateboard U. Okay, so yes. So what you need to do is the file that is called skateboard U. You need to create a new one that has your name. So I'm gonna do it now. I'm gonna copy here the file, remove the prefix as we did, and this is a review. And let's do Daisy. Let's do OK. And I'm gonna commit just that one file, Daisy, and I am going to run PR push. So this is all a review for what we did yesterday. PR push error because the branch is a little. Okay, let's see what happens if I push from here. I think I'm gonna, try this one thing now, but then just leave it there because the other people are, this is kind of failing now. Okay, we'll work on this later, Daisy. But if you want to try and if it works for you, good. So okay, going back to our lesson now. Let's see if I have a branch that says 03 bicycle. I don't, so I go to master. I could have done it with PR pause as well, and I'm gonna PR pull upstream just to make sure I have every change that might have an upstream, and I'm going to initialize a new pull request. So PR init, and we are gonna call this one 03 bicycle. In this case, Mauro. So this, if you can follow along, create your own branch. You should see that now on the Git pane here at the top. So with that, the next thing that we always do in this approach to working with the lessons is, let me see here, is to go to the file that we're going to be working with and copy it. So it's the bicycle U, this one. We are going to create a copy with the suffix of your name. Okay, so let's do just that. Let's copy that, remove the prefix, add the suffix, and we are good to start. One thing we could do is to initialize the pull request by pushing it to GitHub. So I'm going to add that to the staging area, create commit, and add my file. I create a little commit. I close these windows, and I'm going to push with the recommended approach. Push from use this. That sends me to this interface on the upstream repository where I have the ability to check that things are looking good. The commit message is the one that I want, and I can click create pull request to actually start it. There is also the option to choose for a draft pull request. If you are starting a conversation and you are not yet ready to Because once the maintainers see a pull request, they might merge it and they might include it. But if you're still working, then you can say, hey, this is a draft. So I would like your input. I would like to start a conversation, but please, don't yet merge this. I don't know if this is working or not. Yeah, it works. So now you can see that there is a label, gray label called draft. Very strongly sending the signal to the maintainers that this is not ready to merge. They can still override that, and they could merge it, but at least you're saying what you think it should happen, which is wait, basically. All right, going back to the repo, I'm going to click on the file to open it. And before I get into this file, I wanted to quickly show how you create GitHub documents yourself. So if you are playing with RStudio, you may have seen this add file thingy here, and from here you have access to rmarkdown. So I'm pretty confident that by playing a little bit there or going here to new file, you should be able to find rmarkdown documents. But the default is the HTML format, which is fine. You can click OK and see what it looks like. So if I render this with a init, I need to give it a little name for the file so that it does render. It will create something similar to what you saw, but the difference is that the format is HTML. It should have left a record somewhere here. There should be an HTML file somewhere there. But if you want to make it a GitHub document, of course, you could just change in code this to GitHub document. So that would be one way. But what if so you see now it looks more like you're used to, a little different styling, that's the GitHub document. What if you wanted a GitHub document right away? Okay, in that case, you go to File again, or here on the drop-down menu, rmarkdown, and now notice that there is an option that says From Template. When you go to From Template, there is a number of templates that come with different packages, or you could create your own, which is pretty cool. And there is where you have the GitHub document, which is a template that already comes with the package rmarkdown. So by clicking in OK, what you do is you create the basic empty, let's do toy again, the basic empty file that will actually explain to you what a GitHub document is, and it will show with a little toy example, how you can work with it. So that's something that I kind of neglected to say. And also notice that there is some options. Remember that yesterday we discussed this idea of setting options at the global level or at the chunk level, but the options that come by default are kind of fewer than the ones that I like. I generally add here the collapse equals true, and I also add the comment that I like, which is the one that starts with the pound and then follows with this. So it is important to add every time that you add a comment here, it's important to start with a pound, because that's the comment symbol and means that people can copy paste the code that they get from your output into their consoles, and the code will run as code and the output will not work, right? It will just be commented output. Maybe if you didn't get that, it's not crucial now, but like takeaway is in general, all the comments that you want for the output of your documents are it should start with a comment with a special symbol pound, which creates comments. That's the takeaway. So, and with this, I introduce you to this idea of different outputs, right? So you can choose from, let me check here the time. Actually, I have it there. It's 30 past. The idea of different outputs. I've been kind of advocating for the GitHub document because you get for free a web page on GitHub, but you may choose another format. And one format that is very useful occasionally, but when it really is this idea of transforming your document into a presentation with no effort. So, first of all, I would like you to please, once you are on that document and you have changed that so that it has a suffix of your name, please render that file as you normally do with the init button, and have a look to convince yourself that it is, the output is the normal output that you would expect from a GitHub document. The only difference to other lessons that you've seen is that there is, in this case, I have intentionally created headings very often. So there's only little chunks of code that are available only, for every heading there is only just a little bit of code. And that is because we want to fit everything that is in between headings, we want to fit it in a slide. And that is the goal of this very first activity. So how do we transform our document into a slides presentation? Well, the trick, if you want to kind of revisit this, remember that there is a template and there is different formats. So when you create an rmarkdown document, you get also a presentation menu here, and the very first one is the HTML IO slide. So if you do that, it will give you an empty file that when you need it, and again you have to give it a name, creates a presentation for you. So we want something like that, but with the document that we already have. So how do we go about that? So let me just explore what the presentation looks like. Pretty cool. So the use case is that where you are working for yourself first to understand what's going on. Then you tidy the project a little bit to kind of share it with the world. Maybe you create a GitHub document so that you have a web page on GitHub, and you send the link to the stakeholders. You discuss the problem that you explored. You get feedback. You may iterate a couple of times until everyone is happy, and then you present in a meeting, for example, your biggest findings. Now you want to reuse what you did in your work as a presentation. And you don't want to spend hours copy pasting code, things that then something changes for next month, and you need to do like the update for next month, and you don't want to change the presentation again by seeing which slides are out of date, which slides are updated. So instead, much better is to let's close the toy document that I opened. Instead, you can just create an IO slides presentation for your own, for the same document. So you could change here the output to IO slides presentation. I invite you to do that and then render. So with that, we should get a presentation for the lesson that we are going to be covering today. As you can see, if you are careful enough that behind every second or first level heading you fit just a little bit of output and text, then the presentation should just work without you changing anything else. One other way, if you don't even want to change the output here on this line, in this case 3, you can also run this code on the console. So when you basically what the button need, all it does is it runs a function that comes from the rmarkdown package called render, and takes as input a file that you want to produce an output for. So the need button, of course, defaults to the current active file, but you could also specify any other file that exists in your working any file that you can specify here, basically. And then it has another argument that is the output format. You can say, okay, output a GitHub document or output an IO slides presentation, right? So with this little code, you can then leave your GitHub document untouched and create an output that's going to be an HTML file that lives there somewhere, and then you can share it or publish it somewhere. As you can see here at the bottom, I can see the file, the HTML file that resulted from me pressing the need button with the format IO slides presentation. So if I click there and now get like a drop-down menu, I choose view in the browser, and here is my presentation. It's just an HTML file. Even you can share that by email. You can attach an HTML file to an email as any other file, and send it, and then someone on the other side of the world can click on it. It will open generally on the web browser, and they're ready to go. Mm-hmm. 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 Right. Yeah, no, but I will absolutely build on that comment. So yeah, so when you click here click here on the browser, here on the address, you see, it is actually an address to the actual to the local computer, right? So and in this case, it looks a little odd because it's a computer that lives on the cloud. But yeah, you should see something like C, Daisy, whatever, right? Of course, that is a path that won't be used for someone else because that path works locally on your computer. But what you can do is you can email the whole thing. So you can, I'm here on the cloud. So how would I go about that right now? So there is two approaches. The manual one is the following: you click on the thing there, and what you need is to somehow get that out of the cloud and into your computer. So you can go to More on File and Export. This is if you are on the cloud. If you are on your computer, you just copy this. So this is just a file in your folder, right? So I'm gonna download it to kind of show you that now if I go to downloads in my computer, it is just a file in my computer that I can send by email. Okay. The alternative is to publish it somewhere where people can consume it. So in a web server, right? So there is a button that is called this one here that you can configure. It's not configured. I haven't configured it yet, but you can configure it to publish to a service automatically. When you press the button, it's gonna go to somewhere similar to GitHub. My experience suggests that that's doable, and I do it as well. But because GitHub is already serving documents for me, I generally prefer to just, instead of using the HTML format, I just use the MD format and share the link. So how would you go about that in general? So let me show you. So let's say that I want to share a file that I worked yesterday. Say I want to share Freddy's file from yesterday, right? This one here. So when you click the MD, it will appear on the open active file. And there is this little button here that says View on GitHub, right? So there's a little Git pane there. So that will take you, all it does really, it takes you to the repositories that host those files, and it's going to show them. In your case, if you go to the main repository on the 2D organization, and it's not letting me here, well, you scroll down, basically what you see here is the output, right? So it's something that looks like HTML because internally GitHub is understanding that the format MD needs to be converted to this, HTML looking kind of file. So my recommendation would be to just take the link from here, and share it. So this is not pointing to my computer. This is pointing to GitHub, as you can see here on the left, right? That's why I encourage the format MD. But again, HTML is fine to share by email. Okay, so we started with the bicycle lesson. The very first thing we achieved was to create actually a presentation. By the way, I don't know if I mentioned, I don't think I didn't, that the little arrows here allow you to expand everything, including headings. Before, I always was asking to press Alt and O to collapse everything, and that collapses also headings. So that's convenient because sometimes, like I'm doing now, you want to say, hey, I'm done with this section, I just collapse it and I focus on the next one. So as a review from yesterday, we use this button to bring everything down, to run all chunks down. You can always follow options here to, for example, run everything, run the current chunk, run all chunks below, run all chunks above. And also you can insert chunks. So that's another thing that I didn't mention yesterday. So you can click here, insert, for example, an R chunk, which is the default. But I've learned a keyboard shortcut, Control Alt I, and that creates the chunk for me. So that's how I created this rmarkdown document myself. So then we keep running these little chunks. In this case, we attach the packages. We discussed yesterday that the tidyverse contains a bunch of packages, but there are a few other friends of the tidyverse that are very useful. I find very useful, and they are attached here. We also discussed yesterday that you can add images with the syntax, with this syntax. So actually, let's do it. With this syntax, within the parentheses, you could add an image in our Markdown document, and that's great. When you save, it should show a preview, as it did here. But also know that rmarkdown is aware of HTML format. So if you do know how to write HTML, like here, you can. So in this case, what I'm doing is I'm using another syntax, an HTML syntax, to insert an image. And the reason why I do that is because I know how to change the width of the image in a very easy way, and also to demonstrate this idea that you can use HTML. The beauty of the other approach is that immediately shows you a preview on the source code, as opposed to this other approach that only you see the output of that on the render document. So the goal of that image is to demonstrate, again, something that we covered, what is tidy data. So we covered this idea that once you define what a variable is for your problem, then the data is tidy if those variables that you want to work with are all in their own column. And also when the observations, whatever you define as an observation in your research problem, they're all in independent rows. So with that data structure, then all the tools on the tidyverse will work very fluidly. One will seamlessly integrate with other tools to solve your data science problem. If your variables are somehow mixed together, like in this example below, then that is what the tidyverse defines as untidy data. Like for example here, what we have is a messy dataset on the left and a tidy dataset on the right. The messy dataset is so because in this research problem we define that a variable we care about is the variable year, and that variable doesn't exist on its own column. Instead, it's kind of spread across multiple columns. In this case, 1999 and 2000 are both giving me information about the variable year. And instead, what I would like to do is them to exist as values of the column year. So I want to move from this state to the left to this state to the right. And then how do you do that? Well, okay, basically you just find the intersection between, in this case, for example, the column country for the value A has the value 07 on the year 1999, right? So this intersection here, we need to map it somewhere to the right. So for the country A, year 1999, we add another column that holds the value. So these headers of the columns become values of a new column, and the values also become or continue to be values, but they are all under the same column. In this case, it's called cases, but it could be called values. So the default of the functions we are going to be using, but if you say no name in particular, they're going to use the name and value as a way to refer to those two columns that you create when you pivot over the data set to make it wider. So this is a little demo. So we have 1 minute, and I'm going to present the challenge that we're going to be working with next. So we start with this little data set, and I'm creating with this syntax what's called a table, but the function that creates this kind of tables is called tribble with an R, because it's kind of row oriented. And the beauty of this syntax to create a table is that the layout is already similar to what you expect the output to be. So this is really good for little examples, because you can at a glance you can understand what it's going to return. It is going to return a spreadsheet-like data structure that has a column called country with the values France, Germany, and US, and then columns for year 2011, 2012, and 2013 with different values that you could think of as a population or cases of coronavirus, for example. So what we're going to be using when we come back from the break is the function pivot longer. Pivot is this idea of, you have this spreadsheet here with all the years here. I want to put pivot here to break it down so that these columns become values under. And we want a spreadsheet that is like that to become longer. That's why it's called pivot longer. So to do that, what we are going to do is we have to express which are the columns that we want to pivot over. So if we go back to the table, the columns we want to pivot over are these ones here, and you already know a syntax to express, for example, numeric columns. You know that syntax that uses the helper function where, so you can say where the columns are numeric. So that's one way of doing it. The other way would be to refer to this other column and say, okay, I want to pivot over all columns except the column, for example, country. So these columns here to the right go under. So this is what I'm doing in this little demo. So I'm tidying this data set by pivoting over all columns except country. So I'm saying, no, I'm doing it with the approach numeric. So in this case, I'm referring to all columns that are numeric values. So everything except, in this particular case, everything except country. And I just call pivot longer. And as you can see, the default that I get is that the years didn't go to a column called year because the name year was nowhere. So the program doesn't know that I want to call that year. So instead, it gives me a useful default that is called name. And the values go to a default column called value. Then there is tweaks that we can do to this function to make that column name automatically be called year, for example, and values, maybe we can leave it as values, or maybe as metric or something. So, okay, so that is enough for an introduction. What we did is we wrapped up what we did yesterday. We extended a little bit, we refreshed the workflow for working with Use This so that we can work comfortably with R, GitHub, and Git. And we have kind of presented what is the challenge that we're going to be working next. Now we have 8 minutes to the next lesson, so I invite you to take a break and refresh. We are about to import data and start working with it, tidying a messy data set. So let me go back to the code. We covered this already. I demonstrated how this little data set can be tidied with pivot longer where the columns is numeric. So let's run all that code above, and now we are here at importing data. So remember, we are using here as a way to create a safe path that will allow us to move this document around the project, and it should always work, provided that the data remains where it is. So the first thing I'm going to do is I'm going to create this paths variable to contain all the paths to the files that live in there. I'm going to use the function dir for directory, ls for list, so list that directory, so that inside this directory there is a bunch of files. I think we saw that in another lesson. Running that gives me this vector of paths to different CSV files, and we're going to read them all at once with the function vroom, which is very convenient because it is what's called vectorized across over the first argument files. So vroom has an argument. Actually, something that I didn't mention is that if you step inside a function and press the tab, you will have a preview of all the arguments that it takes. And that kind of builds on the comment that Daisy did yesterday about ggplot2. So sometimes you don't even need to go to the help file because just by stepping in here, you get an idea of the arguments and a little description of what they do. So vroom, as you can see here, has an argument called file, and it says that it takes a path to a local file. But actually, that is kind of selling the function too short because it does more than that. It can be a path, but it can be a number of paths. It can be a vector of paths, like the one we are feeding. The paths variable contains many paths, and therefore when I read that with vroom, it will give me what I want. It will read every single file, and then it will put them all together in a single data frame. I'm using here the function suppress messages because vroom is in itself a little verbose. So if I run that in the console here to show the messages, you can see there is some information here that in this particular case I prefer not to print. So okay, we have imported the data similar to what we did yesterday, nothing new there. That's why I went a little fast. And the first task is going to be to actually let's have a look and reflect about that data set. So this, I think we saw this data set before. We have a continent column, the country column. Those are character columns, and then to the right we have a really big number of columns. All of them are doubles, are numeric columns, right? And they contain, the format metric, which is the metric for this country and for this continent, and then the year. So what we want is to pivot over all the numeric columns, and we want to store that result in this vector or this variable called longer. So we are going to use while we do that, we can change the default name that we get. Remember, I showed you that by default you get two columns, one called name, one called values. So we're gonna do a change. We're gonna change that so that the names are called metric. Okay, so the task then is to use pivot longer because we want a longer data frame, and the columns over which we want to pivot are those where the column is numeric, right? So that's one way of expressing those columns. And here we're gonna say that the names should go to a new column metric. And whenever you refer to a new column that doesn't still exist, you use quotation marks. And when you refer to columns that exist in the data frame, you don't need them. So okay, let's run this code and see what it looks like. And the output is what we expected. We have now for each continent and each country, we have a metric column with all the metrics here. At the very end, as you have, I think, population, there you go. And another column that holds the values, right? So that is a little tidy error, but it's not fully tidy because this column metric encodes information that for us is going to be a variable. It encodes two variables actually for the task that we want to perform. So in our research, we want to understand, for example, how life expectancy has changed through time. So the metric life expectancy and time are both in a single column. That's messy. So let's clean that up. How we do that is with separate. So we can separate a column using the function separate. We specify which column we want to separate. In this case, it's the column called metric. And now I'm going to refer to it without the quotation marks because it is a column that already exists in the data frame. Remember, if I print longer here, this column metric, this is the one I want to refer to, exists, so I don't need quotation marks. And then I want to separate what comes from here into two new columns. One is going to be called year, right? It's the right hand side here, it's going to be year. And the other one is metric. And here this might be a little confusing. So well, we are going to create a new one. It's just that new column happens to have the same name that the previous column have. So we chose the same name. So basically we're creating a new one and overwriting the old one. That's why this argument here, it is a vector of all the new columns, and they all need the quotation marks because they don't still exist in the data frame. So let's run that, which I do with Ctrl-Alt-C. I use keyboard shortcuts quite intensively. And now it is clean. So now we have a tidy data set, one row for one column for each metric and one column for each year. Okay, so the next task is going to be to undo what we just did. So we have started from a messy data set, and then we tidy it by making it longer and separating columns that were different variables. And now we're going to revert that. We're going to mess things up. So the opposite of separate is unite. So, if you start from a tidy data set like the one here, then you can unite it. And it works kind of similarly. In this case, what you want to unite are, let me see here, metric and year. I'm kind of surprised because metric has, let me try this. I said that when we refer to columns that already exist in the data frame, you don't need quotation marks, so maybe that was a mistake. So let's see what I'm expecting here. Let me read carefully. So use unite to unite the columns metric and year as metric. Okay, so here this is the as, so this is the new column. So this, I could say new column, and the ones that, so this is the point where it is useful to see the arguments. So let's do F1 to jump to the help file, and here, okay, so the first argument is the data as usual. The second argument is the column. In this case, is the name of the new column. And then ... is any number of arguments that refer to all the columns that already exist in the data frame that we want to combine. So what was there was correct. So here, when I say metric, I'm referring to this column metric that already exists. And when I say year, I refer to this column that already exists. And in this case, when I say new column, it is a column that doesn't exist, and thus it doesn't need the quotation marks. But now, instead of having this name new column, I want to call it metric, because that is what it was called in my messy dataset before. So that is how we get here. So the template was correct. So first step there, it's done. Let's see what's the next item of the challenge. So now we want, remember we started from a wider dataset. So let's call pivot wider to take the names from the column metric and create the new columns and create each of these should be a new column. So let's do just that, pivot wider. So we're going to take the names from the existing column metric, and thus I don't need quotation marks because we are referring to a column that exists, and the values will come from the column that already exists called value. And because it exists here, I don't need to refer to it with quotation marks. So we run that code, and it should now look as the dataset we started with, the messy dataset. So with this, now to go both ways, right? From tidy to messy, from messy to... So sometimes, the actions unite may be an action to tidy your data up. So in this case, I was just using as an example going both ways, but it doesn't necessarily mean that the output of unite or pivot wider is going to be messy. That depends on the data set that you have. So we are about to do to show a few more features that allow you to tidy a data set, but I would like to make a little pause here and get any question that you might have.
I do have a small question. When you use the separate function, does it have implicit that the exact point where it has to separate the names is the underscore? What if we have another type of names? Like what if we have GDP per cap and the number just right after it? Where do we say?
I'm so glad you're here, Daisy. You're asking all the really cool questions. Yes, so there is a sep argument to separate. It is a default to this weird thing that in a jargon called regex. It means all something that is not alphanumeric, so not a number and not a letter. So anything else, it will be broken down. So if the dataset had a period, for example, you should break it there. If it had like a minus symbol, you should break it there. So that's a reasonable default, but it's true that many times may not do what you want. So you can express there either an explicit character that you want to break by, or sometimes you have the ability to express it like here in this regex way. All those symbols just mean a non-alphanumeric symbol.
Thank you.
So it's very, very flexible, actually. Okay, so if there's no more questions, do you have any other question there? Okay, so I want to show off a few other features that are pretty cool to complete missing values, but we need to create a little data set to play with. There has to be a small data set to so it's easier to see what's going on. And I thought, okay, while I create the small data set, let's use or review some of the features that we have been using so far, right? So what I'm going to do, so the goal of this little section is just to create some data to play with, but to review some of the functions we saw before. So we start with this tidy data set, and the first thing I'm going to do to make it smaller, I'm going to get rid of this continent column because I don't need it. And then I'm going to be filtering. Remember, a filter allows us to refer to rows by their values. And I think that so far we have used just one expression that would express which rows we want. But you are not limited to just one. Filter takes the ... argument, which means that you could pass any number of expressions, each of those every time, trying to match rows that meet that expression. So in this case, I'm going to choose just the rows that match the country Argentina, because that's where I come from, and the country Germany, because that is because of the office we are working for, most of us, and then I'm also going to continue to filter so that I get rows that only match the metric life expectancy. And then again, I'm continuing to filter so that I keep the rows that match only the years that are older than or earlier than 1962. So with all of that, I move from a data set that, let's see how many rows it has. So the tidy one has about 5,000, and then if after all that filtering, I end up with only 4 rows, right? So this is close to what I want, but not exactly what I want. What I want really is to have, to take the names from metric, the existing column metric here, and move them, boom, as their own column. So let's do that. And now I have country, year, and life expectancy for Argentina and Germany in the years 1952 and 1957. So those are just 4 data points, but I'm not ready with my subsetting task. I want to continue degrading this data set a little further. Let's see. So the first thing I want to do is okay, so I have this small data set, and I would like to get the mean life expectancy for Argentina within this set of 2 rows, and then the mean for Germany within this set of 2 rows. So basically what I'm asking is calculate the mean for each country, right? So you would express that, for example, with the for loop, but we are learning that there are other ways to iterate over things. In this case, what we are iterating over is over country. So one very elegant way that the tidyverse provides is the function group by. So we group by country, and then we apply the mean. So that's exactly what we're going to do now. So a data set, so I'm going to use now the console for this demo. So if I print the data set to the console, I get a table. And if I print a grouped data set, in this case by country, it looks pretty much the same. Let me print this in the console. But it has this property called groups, and in this case, it's defined as country. So the variable country is the one that defines the groups. That means that every action that we do after it is going to happen within each group. So across along each column, but within each groups. So that means that if I now mutate the grouped data set to create this new variable mean, which is the mean of life expectancy, then I should get the mean by country, not overall, right? So let's run that, and also I'm creating a new column that is overwriting really the year column so that it is numeric, because as you can see before, year is a character because it comes from splitting a character string. So one thing we need to still do is to convert that to numeric. So let's run that and see what we get. So for that we go back here. So having run that, I get, notice how, for life expectancy, I have, one value for 1952 and one value for 1957, but the mean of those is always the same, right? So the mean is 63.4, right? So that's repeated here. And same thing for Germany. So I have achieved what I wanted, to have a variable, okay, it's repeated the value, but it is the single value that represents the mean for the two of the other values in life expectancy here. So what happens if I forget to do the grouping? Okay, what I get is a mean, but now across the entire data set. So I should get a single unique value. So I get 4 because there's 4 rows, but the value is unique. It's just 1, which is the mean across the entire data set. That's the mean for Argentina and Germany combined. That's not what I want. What I want is group by. So again, whenever you think of, oh, this is an iteration problem, you stop for a second before you start writing your for loops and see if there is any approach that gets you there in a more expressive way. And when you're done with your grouping, then you remove the grouping with a function ungroup, and that is important because now we are defining a property that makes that every computation that we perform happens by groups. And if we forget, we may think that we are doing something across the entire data set, and we are not. So it's like good practice to, as soon as you can, just get rid of those groups. So subset 2 should not have any grouping property. So if I print subset 2, it should be just a normal table, not a grouped table. Do we have questions here? The grouping is very important, and you're going to see it again soon.
Sorry, I have another question.
Yeah, absolutely. I mean, it's a pleasure to hear your questions.
Because I've seen a couple of times that when we want to do this kind of means, we also do summarize. So instead of mutate mean equals to mean of the variable, we do something like summarize the variable.
Yes.
So what will be the difference?
Yeah, very good question. So let's try that. So we can summarize. Summarize is a very close friend of mutate. You can also express inside what you express summarize in the same way that you do it with mutate. The difference is that summarize, as the name of the name suggests, is going to create something smaller, just to give you that one thing that you want. So summarize should remove any columns that are not involved in the process. Because this data set is kind of small, I don't think it is making a visible difference. Let's see. So here I have 1, 2, 3 columns. Let's see what happens here. Yeah, okay. So mutate gives me the columns that are involved in the summary. It gives me country because it's involved because it's the variable I'm grouping by. It's giving me mean because it is a column that I'm creating, and it gives me year because it's a column that I'm creating. But then, if I do that with mutate, I get all of that. But summarize, so you see you have 1, 2, 3, 4 columns. With summarize, it will try to get rid of as much information as I'm not asking for. And as you can see, there is only 3. Country comes from the grouping, and mean comes from here, and year comes from here. But there is no column. What was the one missing? Life expectancy, right? So summarize will always try to reduce the data structure, even by removing the groups when you're done. So with mutate, let me see, if I don't do ungroup, with mutate, let me go to the console, and run this code, what I get is still a group data set, right? Because it's kind of expecting more action. So I have to explicitly ungroup if I want to get rid of that grouping. With summarize, the groupings, I believe that it tries to remove them as much as possible. Summarize, no, actually it's still grouped. Yeah. Well, but probably the most noticeable case is that where let's even remove ear, for example. If I'm not using ear here, that's going to be even more visible. With summarize, I should get only 2 columns, the only 2 that are involved in the process of summarizing, group by, country comes from group by, and mean. And with mutate, if I do the same, and run, you see I get all the columns, right? So that's a more visible change. Yeah, is that clear?
Yeah, it is.
Perfect.
Yeah. And maybe because the question is sometimes we want to do like this kind of means not only by one variable. For example, I just don't want to do the mean by country, but also by, I don't know, rating or something like that.
Excellent. Yeah.
So in that case, you think that summarize will be better? Or
it really depends on your job, because sometimes you're summarizing by something, but the data set contains some columns that you still need. So depending on what your job is, you may use one or the other. Notice that this repetition that I get here is also a little annoying. So with mutate, I have this there's one row per country. And the means are repeated here. With summarize. Let's see what we get. Oops. Let's see. No, let's see, get the same. But basically, long story short, it depends on your problem. You will find situations where summarize is the right thing to do, another situation where you need to keep every column, and then you instead use a mutate.
Okay, good, thanks.
So, running that chunk and moving to the next. So now, let me do a little tweak. I'm gonna degrade that dataset a little further because of the examples that I want to show. So I want to get rid of this second row just to fill it later with its mean. So what I'm going to do is I'm gonna remove that row with the function slice. So slice slices your data set row-wise. So I'm going to remove, and I say -2 to remove that one. If I said 2, it would keep that. So let's try that. If I say slice 2, I get just that one row. If I say -2, oops, then I exclude that one, right? Similar to select. And then I also want to remove the mean, just because I want to create a tiny data set that looks just like that. But at the same time, I present the slice function that I don't think we have covered before. So now we have the following data set. We have this data set here that contains only one entry for 1952 for Argentina and 2 entries for Germany, one for 1952 and one for 1957. And we know the means because we calculated them before. So let's say that for some reason we know those means, and we have them now stored here. So we knew from our previous exploration that the mean for Argentina is 63.5 and the mean for Germany is 68.3. So now we would like to use those means that we know about to start filling this dataset. And why do I say that we need to fill this dataset? Okay, again, remember we start from this, forget that we knew the information, the real data before. If we start with this dataset, notice how for Argentina there is no year 1957. And also for neither of the two countries there is information for year 1952, 1953, 1954, 55 and 56. So what if the research problem that we have at hand requires a full data set, requires information for every year? then I mean, saying, okay, let's say that life expectancy equals 0, that makes no sense, right? Because most likely it wasn't 0. A better estimate could be, for example, the historical mean, which is the ones that we magically know. We know them magically. We know the historical mean for Argentina and the historical mean for Germany. So let's do that. Let's try to complete this data set with the information we have. And for that, we're going to be working with a function. Here we have Alex. I think I need to find Alex somewhere in my windows. Sorry, I have Alex joining and I can't find where. Let's bring the screen here. Alex. People. Interesting. Okay, maybe I'll get another. Yeah, I'm not seeing. I saw him coming, but anyway, I guess I'll find him later. Insisting. So the task at hand is now to complete this data set, and as I said before, there is implicit missing data. Something that it is missing because for example, the first job is going to be okay, for this data set. It is very clear that information for 1957 is missing for Argentina, but we don't have an entry for 1957. So how can we make that happen? Okay, we take the data set, right, and we complete it with expressing all the columns that we want to complete by. So in this case, we want, for country and year, that's what we want, information. We want complete information for that. So let's say let's run that. And now, the program has looked into each of those and make sure, now I have Alex. Hi, Alex. The program has gone through each of those columns and seen what are the unique values for them and making sure that the final output has one entry for each of those. And when it does that, automatically we get an explicit missing value for life expectancy for Argentina in 1957. So we are getting there. So now, the next step could be to fill that empty value with. So okay, this is kind of better than say 0 because at least the information is missing, but we can do better than that. We have the information about the mean of Argentina. We can use it to fill that missing value there. So that would be one way of approximating the task of how to complete this data. So let's go that. So now notice that if you have an argument inside complete, and you can step there and press tab or go to the help file maybe. Let's go to the help file. Right, so you have data as the first argument. They have ... which is the specifications, all the columns that you want to complete by. And then you have the fill argument, which has to be wrapped in list. Okay, so let's use that knowledge to fill this data set. Okay, so fill is the argument. How do we want to fill the column? What was the column? Was the column life expectancy, right? So here, so this we want to fill this NA. So the column life expectancy, we want to fill it in this case with the mean from Argentina. We know that mean magically, and we want to inject that value inside there. So that's how we do it. We use the argument fill. So now we have filled that missing value, which was first implicit, then we made it explicit, and then we filled it. So, and conveniently, the fill comes as an argument, but there is also a function called fill that you can use for very similar purposes. So next, we would like to fill, remember that we discussed that there is no information here for 1953, 4, 5, and 6. So what if we wanted a full sequence of years by year, by 1, right? By period of 1. Okay, so in that case, we can use, what we're gonna start doing is first pull the column year. So we have the data set that we're working with, and we want to pull year first. So that gives us just a vector of the few years that exist in this data set. But then we want the full sequence using those kind of scattered data points. The function fullsec, what it does is just look at the whole thing and fills the gaps, right? So that is what we're going to achieve. Specifically, if you say period 1, you get one data point per, in this case, a unit. So that is the vector that we just created that we are going to inject now to complete, to do something similar to what we did before, but now in the variable year, we are gonna not just use the same variable year, but instead use this vector that we have just created. Actually, we are fields. Okay, so use all the vector all years to complete, right? Where year should be all years, right? And country, country had no problem. These two countries that we know of, and the two countries that we want to analyze. So it's complete already. So we can fill it with itself. Right. Okay, let's see how that looks like. So now we have a data set with values where there is values and missing values where there isn't. So if I go to the bottom, so for years 53, 54, 55, what we have achieved is what we're intending to first make those implicit values explicit. At the bottom, we have these other two values for 1957, and we have information for those. But now the next step is going to be to inject values using what we know. We know the mean for Germany, we know the mean for Argentina, we magically knew it, so we want to inject it in there. How do we go about that? So it introduces you to another function that is like a special case. You might have heard the programming ideas of if and else. If this happened, then do this other thing. So case when is like an alternative for expressing this idea, what to do in different cases. So you express the concepts in a very clear way, so it really scales up very nicely, as opposed to if else, that it is very useful when you have few cases, maybe 2 or 3, but then when we have more cases, it gets really difficult to write and to understand what's going on, because you end up nesting one if else statement inside another. So we are going to combine case when inside mutate. So the way it works is as follows. So we take full mean, the data set we are now with this data set that has a bunch of missing values, and we want the cases where Germany is missing and the cases where Argentina is missing. And in each of those cases, we want to do something different. So when Argentina is missing, we want to fill with mean for Argentina. And when Germany is missing, then we want to fill with the mean for Germany. And then there is a third case, which is the case where there is data. We do not want to overwrite with the mean data points that are real, that exist, that we collected. So then when Argentina or Germany are not missing, then we want to keep life expectancy as it is. So how do we express all of that succinctly in code? That's how we're going to do it right now. So we're going to call case when. And case when takes a bunch of cases. To the left, you express the conditions, and to the right, you express the values. So in this case, for example, we say when is a life expectancy, when the life expectancy is missing. So with this, I have said like every single value here, whenever life expectancy is missing. And now I have to specify more precisely, okay, and Argentina is the country. So, and the country is equal to Argentina, then use the mean for Argentina, 63.5. And similar for Germany. So when life expectancy is missing and the country is Germany, then the mean that I want to use is a different one, is the mean for Germany. And then I need to catch every other case. So those are the two cases that they resolve the problem completely, because every other case is the case where life expectancy is just fine. So it just should stay as it is. So the way it works is that every of these conditions will resolve or will evaluate to either true or false. This you can think of this as a question. Is life expectancy missing? Yes or no? Is country Argentina? Yes or no? So when this condition evaluates to true, then we inject the mean for Argentina. When this condition evaluates to true, then we inject the mean for Germany. And any other case, so wherever else we get it true, then we inject life expectancy. So that is the catch-all case. Almost every case when should have a way to catch what's happening after. You could sometimes catch like an error and stop the function and throw an error saying I don't know what you're talking about, or send a message saying this is unexpected. In this case, every other case we leave life expectancy as it is. Let's run that code, and here is the result. So you can see that wherever we had life expectancy values, the values did not change, but wherever the country was Argentina and life expectancy was missing, now we have the value for the historical mean life expectancy for Argentina. And the same for Germany. Wherever the country is Germany and life expectancy was missing, now we have the historical mean for Germany. So that's the same everywhere in the data set, right? Again, it's not perfect, but it's much better than zero. And in some circumstances, you cannot deal with the missing value. So if you have to fill them, here you have an approach. And now the fun part, we're going to do a little plot to visualize what we have just done. Do we have a question here? No? Okay. So the tools that I've just shown, case one is pretty commonly used. The task of filling and completing depends a lot on your data set, so you may not use it a lot, but probably precisely because those tools are not super, so it's really difficult to do what they do by hand or to figure out how to do it. So it's really good to know about them, but unfortunately we don't use them like so often in general, or luckily maybe, because it's a bit of a pain to fill data. So we don't use them that often that they are always fresh in our brain. So it's kind of good. It's documented here. Whenever you need them, you may have forgotten how to use them, but you know their names. You can find information in the help file and on their websites of the packages that they belong to. And here you have some use cases to understand what's going on. So now we're going to create a little plot. This is the first time that we are going to overlay several layers, and it's the first time that we are going to create a facet. So let's see what that is. So we're going to create a plot of life expectancy by year. Time sequences are nice to see year on the x-axis. That kind of makes sense from left to right. So let's do that. You know already that this actually means that. And life expectancy on the y-axis. And we want to do a line plot, right? So we want to represent data with a geometric representation equal to line. So we're going to do a geom line. Again, if you need to remember what's the geom name for different representations, then you just go to the website of ggplot2, you screen the page of that is tab is called reference, and then you will see not just the name but also little pictures that show more or less what you can accomplish with each of those. So let's run these two things for now and see what we get. So we get a little bit of an odd plot. So we do get the year on the x-axis, and we have the life expectancy on the y-axis. And the reason why this is jumping up and down is because there is still a problem of grouping. So the plot doesn't know how which points correspond to one country and which points correspond to the other, and it's trying to just the line plot is just trying to find the point. And to join the points just by sequence, right? So if I replace this with, or even I could add it with point. So So let's create the points and put them at the top of the line. So you will have now probably an idea of what's going on. So what you see is, these points are for one country and these points are for another, but geom_line is trying to join them all. There is an argument called group that you can use inside the AES specification that will solve the problem for you. You could say the grouping is country, and when you do that, then the lines will know which country they correspond to. But instead, we could also do something different, which is just to plot each country in a completely separate plot. Then there is no more ambiguity. So that's exactly what we're going to do now. So let me expand this a little bit so it fits here on screen. Well, it doesn't quite fit. So let me comment this out for a moment. So the concept I want to introduce is this idea of dividing subsets of data in different panels, and that's the concept of faceting the datasets. And that's a concept that exists in other contexts, not just in ggplot2. So we're gonna create a facet, and we can use, there's a couple of flavors. The one that we are gonna be using now is Facet Wrap, and you say with this formula syntax, which is the facets that you want to create. We want to create a facet by country. So we get one plot with, very conveniently, with the name of, with the values that the country column contains, are like the headers of each of those plots. So very conveniently, and now there's no more ambiguity, so I don't need the argument group. That's why in the example it's not there. And notice how this is kind of jumpy, and the reason is because, now that we know, so we have real values here, and we have real values here, but then the rest of the values come from the mean. That's why it's flat, because we have a lot of data points that are just, we didn't know really what they were, and our best guess was to use the mean, right? So how could you express that visually? Okay, one way could be to create a horizontal line. So there is a geom that is called geom h line for horizontal line that takes one argument, which is the y-intercept. So you can check the documentation for it. I think we discussed this with Daisy and everyone yesterday. In every help file for ggplot2, geoms has a section called aesthetics that tell you which are the compulsory aesthetics that you have to use and which are the ones that you can optionally use. So in this case, the argument that we need is the y-intercept. So if you're going to just plot a line, you have to express where along the axis, the y-axis, that line should intercept. So it's going to intercept where in two places. One is where the mean is for the mean of Argentina, and the other one for the mean of Germany. And we can also define the type of line that we want. If we don't, it will be just a straight line, but then it will get confused with the background line that represents the actual data. So what we're gonna do is create a different type so it's easier to see. Geom, there you go. Committed a typo there. So now what we get is this faceted plot, the data points for Argentina in one panel, the data points for Germany in another panel, a dotted line to express the means, and then a full line to express the connection through time of life expectancy for each country, and wherever we don't have information, we just guessed it was the mean. Takeaways. Before the takeaways, do we have questions? No. Okay, so I'm going to render this and go through the takeaways on the output because they're easier to read. We have 3 minutes to wrap up, and then we go to the break. So takeaways, plotting task. Okay, we learned to import multiple files at once into a single data frame with vroom. Not remember if we saw this in other lessons, but vroom is very powerful. It does a lot for you. And we're going to break down what it does in the next, not in the next, 2 sections from now. In terms of tidying data, the tidyverse is an opinionated framework. It has a definition for what tidy data is. In short, it's that kind of data where whatever you define as a variable lives in its own column, and whatever you define as an observation lives in its own row. If you have that kind of data structure, then working with tidyverse is going to be very easy. If you don't, then you have some tools to reshape the data, like tidy pivot longer and pivot wider, which correspondingly make your data sets longer or wider by moving, like breaking your data set over some columns and making them values of two new columns. One that is called name by default and the other one that is called value by default, but you can choose whatever names you want and specify them even within the call to pivot longer. And pivot wider does quite the opposite. So you can also use then unite and separate, because not always the columns that you have contain a single variable. Sometimes, like in our case, we have one column that contain metrics and years encoded as values. So we wanted to separate them wherever we had underscores and non-alphanumeric value. By default, separate will split that. And then we use fill, complete, full sec, and case when in different circumstances to fill missing data. Many times our dataset have implicit missing data, so we can use these tools to first make them explicit and then to fill them. And how you fill them is totally up to you. The one approach I showed today was using the mean for different groups. In terms of transforming data, that is we learned pretty new to group by. I think I forgot to add it here, to group by and perform tasks within groups. We probably saw for the first time mutate as well, and we also saw an extension filter where we can filter by several expressions, not just one. And we reviewed, we saw again and again that the helper function where is convenient to select columns, not just inside select, but also you can use it inside pivot longer and in many other places in the tidyverse. So basically the concepts that we learned before, are going to be reused in your data science tasks. For plotting, we learned about this new idea of faceting data and putting different groups of data across different panels. And you can extend a basic template by adding many layers. So the plot today had many layers, had like a geom line, a geom H line, and then had a facet wrap. And in terms of communication, I showed you how you can knit a document using the IO slides presentation format, which is very convenient to transform a kind of a long document like the one you are looking at now, to transform it into a slideshow presentation without you needing to change anything. So that's the end. Any questions before we go to the break and reconvene in 9 minutes? Okay, so thank you very much. Probably you're free to go now, but what I'm gonna do in the next minute, maybe in the background, if you're interested to look, is I'm going to actually clean my Git history and push a commit to the repo. Okay, so if you wanna go. If you wanna and see how I'm working here, go ahead. I'm gonna expand my window and work for the next minute, and then I'll be back here at the top of the hour. Thank you.